We are looking at two different problems in Merlin. The first one is about minimizing losses in the rail power grid. We are examining a line between Malmö and Alvesta in southern Sweden. It's a double-track line with quite heavy traffic, daytime mainly passenger traffic, and during night freight traffic. There are 3 converter stations on the line, and we are seeing that these converter stations not just are feeding the trains near the station, but also over longer distances. And this causes losses and energy costs money. So by changing converter parameters, we hope that it should be possible to minimize the losses, and that will be done by simulation by Siemens. The other line we will look at is from Malmö to Simrishamn with a converter station in Ystad. And this is a single-track line with quite heavy suburban traffic. EMUs used on the line have quite high installed power, so we get very high power peaks. But these power peaks are just a couple of seconds long. And their idea is if it is possible to shift these power peaks, like just a few seconds earlier or later, we can maybe reduce the peaks by 30% or so without affecting the timetable. And then this way we are hoping that we can lower our investment costs. And also this will be done by simulation, and there we will see if it is possible to do that without affecting the trains.
Our task was to study the 2 cases. The first case regarding energy efficiency, with the task to reduce the losses by adapting the converter parameters. To be able to do this, we developed a converter model which has been used and in our simulation tool CityTrack, and also did an iterative process to optimize parameters with the tools which have been developed in Merlin. So for the first study object with the reducing energy in the system looks quite convincing, so we optimize parameters, but are still in the progress to find how much we could reduce the power. But it tends in the right direction, that the energy in the system could be optimized by this method. For the second task, where we should look if we could reduce the power peaks of the system, we had 2 approaches. One approach was to modify, let's say, the train starts, the departure time of the trains, and the second was to alter the driving profile of the trains, taking into account not to shift the timetable. We already have preliminary results. Power peaks in the substation could be reduced by approximately 20%. The conclusion, both targets could be reached by optimizing the converter parameters. The energy flow in the system can be optimized, and also the energy demand could be reduced, so losses could be reduced. And the second subject looks very promising, and I think that it is demonstrated quite well that only short modifications in the timetable can reduce the power peaks, and then the goal of traffic work can be reached by that.